Hello folks, back again. This is the part 2, chapter 11 slides in the chapter on interactive graphics. Although we're not doing much interactive this chapter, we're just looking at some more refinements with the ggplot2 package, giving you an idea how to learn to do fancier things. So we're still in the visualize phase in the big picture of data science. I'd like to talk about annotating a GG2 plot. So in addition to the regular MDSR package or perhaps tidyverse, you're also going to need to library the baby names package to get at the baby names data table. So let's make a familiar type of data table. Recent princes shall be baby names filtered down for the name to be equal to prince, either male or female, and the year of birth to be at least 1970. And what we'd like to make is the plot that you see here. So it's a simple line graph of the popularity of the baby names, of the baby name Prince, for both females and males since 1970. The y-axis has the number of babies per 10,000 people of the given sex that are born each year. And what's special about the plot is the annotation. There's a little bit of text. Purple Rain, released 1978. That was a Prince's breakout album, released in 1978. And an arrow going from the text down to the year 1978, pointing at where the male births were in that year. So how do we get to a plot like that? The text turns out to be centered at the year 1984 and at the level 2 people per 10,000. Okay. The curve starts very close to that, a little bit underneath the, underneath the center at the level 1.9, and ends at that 1978 male point. So one thing that we'll want to do is find out what is that 1978 male point. So I'll call it male prop 1978. What we do is we take recent princes and filter for the sex to be male in the year 1978. Now that is going to be a data table with just one row, but we need to pull out the prop column, the proportion of males in that year that were born with the name Prince. So that's the final bit of our wrangling. And the result is a numerical vector of length 1 that is that proportion. And here it is printed out. So it's 4.27 times 10 to the negative 5th. And what we'll do is we'll multiply that by 10,000 to get the number of babies out of 10,000 that's born with that name. And I'm sorry, it's 4.27 times 10 to the negative 5th is 4 in 100,000 babies. So multiplying by 10,000 would be a 0.4 out of 10,000 babies that year born with the name Prince. So that's the level we want to get down to with our arrow. We need to pack up the data in a nice table for ggplot to use. So I'm binding the name text. You could use any name, but I'll use text to be the result of making a data frame that only has one row, but it has 3 columns. X is 1984, Y is 2, and label is the text. Purple Rain released 1978. We're going to also make a second data frame called segment. And this records basically the beginning and the end points of the arrow. X1, 1984, Y1, 1.9 are the X and Y coordinates of the beginning of the arrow. X2, 1978, and Y2, male level 1978, are the ending point of the arrow. So what we'll do is we'll take recent princes and we'll pipe it in as the data argument for ggplot. The standard aesthetic mapping, x-axis mapped to year, y-axis is mapped to prop times 10,000 to get the number of babies out of 10,000 born in the year. We need to have a geom line for the line plot where color is mapped aesthetically to sex. And then we begin the new stuff. So to get that text in, we do a geom text. And the data changes now. It's no longer going to be recent princes. It's going to be that data table text that we made. And we aesthetically map an x coordinate of the text to the x variable in the data frame, y in the text to the y variable of the data frame, and a label aesthetic in the text to the label in the data frame. You see those three variables here. I'm giving those columns in that data frame the same name as the official recognized aesthetics for the text geom, X, Y, and the content label. Now, there's other parameters that are outside the call to S. You can justify the text to be left or right or center. I'm going to center the text at that XY point. You can specify the size of the text. I'm going to make it a little larger than usual. And you can set the color of the text. I'm going to make it be purple. Okay, here comes another geom. This is going to be an arrow that is a little bit curved, so I use geom curve. I need to switch up the data that is being used to make the curve. The data frame now goes to that segment data table that I made. And a geom curve recognizes aesthetics for the beginning and the end points of the curve. X coordinate of the beginning curve is X. X coordinate of the end curve is X end. Y coordinate for the beginning is Y, and Y coordinate for the end is Y end. And so I map them to the appropriate beginning and end points from segment. You can specify how curvy the arrow is. I'm setting the curvature to 0.2. And the arrow parameter allows you to specify things like the shape and size of the little arrow at the end of your curve. And then finally, we add on our labels. We don't need anything on the x-axis, and the y-axis we wanted to be that text. So that's how we got the recent princes plot. Another little interesting refinement comes from the package GG Extra. You can actually make marginal plots and tack them on to a regular GG2 plot. So here we have the iris data. That's the 150 irises, 50 of each of 3 different species, Setosa, versicolor, and virginica. And we've got a scatter plot where on the x-axis we have the petal width, and on the y-axis we have the petal length. And the species are color-coded, but what's cool is in the margins we got a histogram for the petal width, and that histogram is broken down by color to indicate which species are being represented in which parts. Same for the histogram of petal length. on the y-axis. So how might you get such a thing? It's all coming from the package ggextra. So if you want to make such a plot, you might library it. And the most convenient thing is to use an add-in that gets installed when you install the ggextra package. What you do is you'll just make a regular old ggplot, but you'll save it somewhere. So here I am binding the name plot to my iris plot. And then somewhere else, just have the expression plot, the name of the object that you made. You'll highlight this. You'll highlight this name like so, and then you'll go to your add-ins and find ggplot2 marginal plots. Let me illustrate this procedure for you. Go to RStudio here, and first of all, I'll get myself out of the way, and I just make the plot so you can see that it really is a regular old plot. So I've got plot in my global environment, and then I just evaluated plot, and now I see, yes, here is this regular old plot. Great. But what I'm going to do is highlight it with my cursor, then go to add-ins, and then I'm going to search until I see ggplot2 marginal plots. Move this over a bit. And I'm on the main options part of the add-in. I can specify what type of plot goes in the margin. Right now it's just density plots. I think I'd like histograms. And I'm content to have it on both margins. Size ratio looks good to me. I mean, I could play around with it, but I liked it the way it was. I'll go to colors, and under colors I can either set the colors with like a color picker, like I could have any fill that I wanted, but I'm going to do the fills not as one fixed thing, but I'm going to show groups as fill. And so I got the species color coded. There are some advanced options as well, but we won't play around with them now. I'm just going to go note that you can get the code if you want. You can actually get the code that produces that marginal plot. I don't need to grab the code right now. You certainly could with a little copy and paste. I'm just going to press done, and you'll see what happens. Back in the R script, you see that the name plot just got replaced by the call that produces the marginal plot. So, getting myself out of the way here, if I were to go and run that call, then sure enough, I get the marginal plot. So that's pretty excellent. So there are hundreds of refinements of that sort that are associated with the ggplot2 package and with various packages that have been built to extend its functionality. You can learn about a lot of these in the online documentation, which is here. Here. You can look in the reference, get basically a description of all the different functions and how they work. There's a few other articles that are interesting when you get more advanced. In addition, there is an online book. The third edition of the book is in progress, and it is free online. It's written by the author of the ggplot2 package, and is worth a look if you want sort of a profound understanding of how the system works. So again, another great possible project is to delve into some of the refinements of ggplot2 and produce a presentation for us about them. That's all for now. See you next time.